Hey, Devarao and Aman. Thank you for joining to today's Python Fundamentals Study Jam. And as I said in the previous study jam, we already finished this Kaggle Python course, but we still have one more tutorial that gives you a first step into joining Kaggle competitions. This is the Titanic tutorial. Let me share the link with you so that you can start with me, following all the way through this tutorial. So Kaggle is very famous for its competitions, and there are many tutorials for you to try and study, and then you can join other competitions that have some prizes, or you can just learn a lot from them. And to start the competition, we need to go to the competition page. Let me know if you don't see this tab. You see this tab, right? The new tab. Okay. So here we have the overview of what this competition is about, and we are interested first in the data. Let's see next what we should do. So we have the Titanic passenger data, which have the name, age, price of ticket, and other information about each passenger. And on the data tab, we can find 3 files: train CSV, test, and gender submission CSV. If you look at this data tab, we see here 3 files. And we can explore what's inside these files just by clicking each of these name on the files. For example, this is the test CSV file, and we have here passenger ID, class, something, name, sex, and that's it. But for for train CSV, we also have survived tab, which means we have all descriptions for the passenger and whether these passengers survived this disaster or not. Let's see next. And you notice that only the names and the sex is in the string format, and passenger ID, survived, and the class or the age are in the string format. And the classification is if the passenger survived, then it's 1, and if passenger died, that it's 0. Example is Owen Harris, which died when he was 22. And as we already seen from the test CSV, we have the same information except the survived column, because this is what we need to predict. This is what we need to test. And the gender submission file. This is the example of how we should structure our submission. And we should have the passenger ID column and whether it survived or not in the survived column. Now, when we know this data, when we explore this data, we can then proceed. This is just a quick exploration, and then we just proceed with the code. We need to go to the code tab. And before we go to this code tab and start our practice, I want to also show here the discussion board. And you can also see the submissions of other people. So if you're not sure how to proceed, or after the submission, you want to study how people solve this problem, what were their solutions, it's a great place to study other ideas. And also there is a rule. So because I already signed up for this challenge, I have no button join the competition. But for you, you should have the join competition button in the overview tab, and you need to accept all the rules that are listed there. And once you've done this, we need to create the new notebook. I'll close this tab. And this is the notebook that we have to submit our files. And you can name it as you wish. For example, day 1 ML challenge, Titanic. And as usual, we need to write this boilerplate code that stops the environment. Once it's set up, we will start with our analysis. And this is already, I explained. Now, today we're going to use the NumPy and Pandas libraries that we already practiced a bit. And as I explained in the last session, we need to use, so let's create new place for code. And in order to use some external libraries, we need to import them. So we use import keyword and the name of the library, and then we can use alias for the name that we want to save this library as LB and panda. Okay, now that we've done this, let me see. Oh, okay, so actually it's already done here. I don't need to type it. So we imported 2 libraries, and then we already seen this output. What is this? This is the import OS library that helps us to navigate through our files and folders. So we have here the for loop. We have directory name, file name in this directory Kaggle input, and it will go through other directories and through the files using the walk method, OS walk method. Then there is another for loop. So this is the nested for loop. And for each file name in the file names, so imagine we are in the folder input, and then this input folder has other folders, for example, Titanic, right? So this is the directory name. And then this Titanic folder has different file names. So we go through the file names. And then for each file name in the file names, we print the path using the path.join. So this is the, we say, I forgot the term, but this is the library or sub-library, right, of this library. So we use the path.join, or this may be a method of this library, to print the directory name and the file name. So here we have all the file names from the Titanic folder. And this is actually the files that we have seen before: train CSV, test CSV, and gender submission CSV. Okay, so we don't need to write it here. Let's go to the next block of code. Now that we've loaded our data, we need to read it, or we need to read it and to inspect just the beginning of this table using this method. Let's just copy it for simplicity. Okay. And so when you're going to start other tutorials, you have some codes. And when you start the competitions, probably this is what you need to use. This is like a starting point for you. If you want to load the data set from the competition, you will use this code. Again, this is what you use to read the table. So we use the pandas read CSV method, and we specify the path in the argument. Means we want to save the this file, train CSV, as training data, corresponding name. And then we use the dot hat method to just print the first maybe 10 or 5 to 10 rows. Let's run this code. Oh, there is some. Some mistake. Let's see. Okay, so instead of just simply copying, we copied exactly the path that was listed, and we have no mistakes right now. So this is the train data, and we have here just the index. We don't need to think about this for now. We have the passenger ID. So this is just 5 rows, whether the passenger survived, the class that they bought, the name, sex, age, something, the ticket, fare, cabin, and embarked. And we already noticed here that some of the rows have no data, and that's why we have the non value here. So once we explored a little bit of the train CSV file, we then need to proceed with the next 2 files. And let's add here the code. Again, I will just copy exact path that was listed as an output. And okay, so this is the test data, and it's the same data, not the same data, I mean the same format of the data, except there is no survived column. And here we have more unknown data, no empty data, no values. By the way, the train data contains about 400 or 500 approximately data points, so data samples. Let's see exactly how many samples we have. Maybe it's listed. Okay, so it's twice more, so it's almost 900 passengers in the train CSV file, and the test data contains 400 passengers. Okay, then we need also to start the last file, gender submission file. So gender submission CSV, maybe we just need to write this code in this environment. Let me explain what we have here so far. Let me check. Yes, let's proceed further. So we have here a new variable women, and from this train data that we have loaded, we will locate, or we will find the sex column here, or maybe here. And if the sex is equal to female and it is survived, we will save this data to women. So this is the why we need this, because next we need to calculate women, the ratio of women that survived, and we calculate it by summing up women number of rows for women survived to the to the length of this table, and we need to print it. Okay, we have again mistake. Women train data. Okay. Interesting. Okay. Somehow just running this one by one will give us no error. Okay, so we calculated the rate of women survived. It's equal to 0.74. And then we will need to do the same for men. Why is that? Because in the Titanic tutorial explanation here, I think maybe let me find it. We're gonna try the simple analysis, which is our first prediction, first attempt to predict the survival rate for the dataset. And our first hypothesis is that the survived person is the survival of the person depends on its gender. So maybe it's not the good hypothesis, but it's the first hypothesis that we have. And after we do this first tutorial, you have a free, let's say, you have an option. If you want to proceed with other hypothesis, you can check it. For example, the hypothesis can be the ticket or the cabin that they booked. Maybe the what else could be here? Maybe the fare, how much it cost. Maybe the cabin, maybe the class that they were booking affects the survival rate, or maybe it affects the survival rate altogether, not just one characteristic. Okay, and let's proceed with male or men survival rate. And again, I'll try to run separately. And we have here men who survived. The percentage is significantly less than for women. It's almost 0.20, so 20% of men. So just having this kind of exploration, using these statistics, we assume that maybe the gender affected the survival rate. Then let's build our first machine learning model. And here they introduce us to the random forest model. And as the name suggests, there is something related to the forest, the trees, right? So we have here a tree, which the first tree that classifies passengers according to their sex, for example, the female and male. And then each of these category is classified next to another subcategory. And we can proceed further and further, which creates this kind of tree. So this is why it's called the random forest model. And let's define it using this code, and I'll explain in as much as detail as I know. So again, we need to import libraries. So we import sklearn ensemble. We import the random forest classifier from this library, and I have prepared here the link to this model. Let me share it with you. So I want to show you how to use the documentation to get some insights of what this model does or what parameters we should use. For example, let's see. So this is the description. This is the random forest classifier, which fits the number of decision tree classifiers on various subsamples of the data set. And it uses the averaging to improve the predictive accuracy and control over fitting. So we have here explanation, short description, how it, what method it uses to improve the accuracy. It uses the averaging. And we control the subsample size using the max sample parameter and bootstrap. Otherwise, the whole dataset is used to build each tree. Okay, so we know here that we can control the sample size using the two parameters. And this is the list of all parameters that can be used. Some of them are optional, or maybe all of them are optional. Let's see. And what I like in these documentations is that after you just get some idea, the description, you can then see the example of its implementation. And let's see what exactly we're going to use for this method in this example. So we first define our, so we will have the independent variable and dependent variable. Our y value is going to be the predicted value, which is the trained data survived column. So we here define y as the column trained data survived. So this is the survived column. Next, we create the features column. And this is the, what kind of data type? It's a list, right? A list of strings. And this is the features that we're gonna consider as the like markers that define whether the passenger died or survived. And here is 4 features. We can find these here, actually, in this table, P class, and some other tables, columns. Next, we define our X. So X is the values from the columns of features that we define here. And here we use the get dummies method of pandas. And for example, I don't know what does it mean. I'll just Google it and I can see the documentation page for pandas as for this scikit-learn machine learning library. And here again, I can see the short description. So this get dummies method converts categorical variable into dummy indicator variables. And if I don't understand what does it mean, after reading the parameters, finding some parameters that might be useful for our analysis, for our task, we can here see the examples of using this method. Let's see what parameters they use. They use just one parameter, which is a list of features. And let's find here. Okay, so probably this is the data parameter, and it can be in array-like or series or data frame format or data type. And this is the data of which to get dummy indicators. What does it mean, dummy indicators? Because we don't use other parameters here, I won't spend time to study them. Maybe I just noticed here is the columns. So we can specify the columns, right? So this is the columns from our train data. And this is the list like or default none. This is the column names in data frame to be encoded. So actually this fits us more because we have the data frame and we use column names to extract the values from the columns of our data frame. So I think this is the parameter that we're going to use, and this is the only parameter we're going to use. Now let's see the examples of using this method. And we see here everything is 0, 1, 0, 1, 0, 1. What does it mean? When we extract the data from our table, for example, the sex is a categorical data, right? It can be female and male. So it will convert the strings here into the 0, 1 category. So instead of string, we're going to have integer values. Why is that? Because it's easier to work with integers instead of working with strings. And we do the same for the X test. So X is our training data set, and X is the test data set. And we use the same method here. But we should be accurate, because instead of using the train data, we should specify here the test data. Now let's define our model. We use the model variable, and we use the random forest classifier that we have imported, and we specify 3 parameters. Now let's remember, so this is n estimators 100, max depths 5, and random state 1. And let's find it here. By the way, do you know why they use this notation to specify the parameters? Why we just cannot use, for example, 100, 5, and 1? Do you know? Or why we don't use n estimators, max steps, random state, just as it, without specifying equal to 100, 5, or 1? Because before we solved some problems and we use the name only in the parameter. But here we use this format. Do you know why? Any idea? Abdullah, you don't have an idea, because I think it's related to, maybe you have already encountered it in Android development when we covered some constant and default parameters. So first of all, we don't, as I understand this, we don't use just integers, because we see here there are like 10 or more parameters. And if we use, I think, in the order, then we might have no errors. But if we define, for example, 1, 2, 3, 4, 5, to each of these parameters, they will get these values into the parameters. But if I, for example, want to use or parse only certain parameters, then if I use only numbers, then probably it will think that I defined n estimators, criterion, max depths, and that's it. So there must be some errors. Another thing is, here you see that an estimator, for example, is an integer data type and it has default value. So if I just if I don't specify n estimators, then it will use so what an estimator is the number of trees in the forest, and it will use default value. But imagine that I know that I need to use 200, for example, and I don't specify the n estimator, then to use exactly 200 number of trees, I need to specify n estimators. So what we have here in the code, we specify n estimators 100, but we already know that it's not necessary because the default value is 100. So we can skip actually this argument. Let's see next, max depth. So this parameter is of integer value and default is none. Okay, so what's this is maximum depth of the tree. So if none, then nodes are expanded until all leaves are pure or until all leaves contain less than minimum sample split samples. So the max depth is, as we saw here, is the depth of this tree. So maybe it's like a length of this tree. And we use the max depth equal to 5, because otherwise, if we don't specify this parameter, we're gonna have none, max depth equal to none. And then last parameter is random state. Let's see random state. Okay, we see here it's not even close to these other two parameters. Random state, it's a integer data type, and random state instance or none with default value of none. So we see here it controls both the randomness of bootstrapping of the samples used when building trees. Bootstrapping is, as far as I know, it's a query or access of data, some samples of data. And we want to ensure that we get data by random chance. So this is useful. This is necessary because we might, if we don't use random bootstrapping, then we might pick up data that has some pattern, and it will affect the outcome of our model. And when we define the model here, we need to fit our x and y values, the independent and dependent variable. And then we define predictions, which is using this training data or training model, the result of training a model. We will predict what is going to be the value of y. So this is actually predictions. We can name it y test. So what would be the y value if we use new data? The new data is our test data saved as x test. And then we just want to print the results using this, the rest of this code. We define output as a data frame. And this is going to be our data frame. So it's going to be like a table with the two columns. First is passenger ID, which is the test data passenger ID. This is column 1. And next column survived. And it's going to be our predictions, the result of this model prediction. And then we want to save our output to CSV file using toCSV method, and we don't use the indexing. And just print that we successfully performed our first machine learning model training and prediction, and we submitted our first version of the solution. Now, when we know the meaning of this code, let's see the result. Maybe we have mistake here because it's frozen. Okay, sorry, my PC was frozen. Let's run this code. Okay, so it was pretty quick. We have here the output, your submission was successfully saved. So we know that the code was run and we've got this output. Okay, let's see next. And what we need to do is we need to click the save button or the save version save button. And then in the output tab on the right of the screen, we need to click submit to submit our submission CSV file. So let me see. So let's run the save version first. So this is version name. We say gender hypothesis 1, for example. And we specify that we tested the gender effect. And then we save it. Okay. Let's find the output code. This is our data. Okay, so this is the submission CSV that we've created. It's in the data tab. And okay, so we see here that we have the user, or not the user, the passenger ID and predicted value if it survived or died. And I'm trying to find where is the submission. This is our log, comment, and or maybe I already submitted it before. Okay, not sure. Oh, okay, open in viewer. Okay. And okay. Actually, submission was saved, and then we need to go to the output tab and click submit. But I'm not seeing any output tab. Oh, okay. We can submit to competition here. Just on these three, let's say, okay, this is our notebook, version of this notebook, submission file, and the description, submit. So let's see, submission. Okay, so I see here my submission, and my score is 0.77. Interesting. So do you have any questions about this Titanic analysis? So I recommend you to go through this first tutorial, and here in the last section, they recommend us to start intro to machine learning, but we study machine learning on Fridays actually. And before you go to this course, I recommend you to go through this code and try to experiment with this, because here we use these features. And as I said before, you can use other features that you think might affect the survival rate. And then after you do this model training, you can check your score, whether it was increased or decreased. So this is the public score, okay? And this is our maybe first application of using Python. As I remember Dimaral asked what she can use Python for. We can use for machine learning. And we're gonna start our journey for data structures, algorithms, no, maybe object-oriented programming to create some games. So this is another application of Python. And as we have a little bit time, I prepared some programming exercises for you today. Let's start with the program like this. Yes, this is the problem for today. This is the link. So the problem is we are given an array of unique integers saved as salary variable, and salary index I is the salary of the I employee. And we need to return the average salary of employees, excluding the minimum and maximum salary. And this exercise is suitable for our today's practice, because when you do simple, before you run your machine learning algorithms, most of the time you're gonna collect data, you're gonna explore data, clear data, prepare data, transform data. So everything related to your data. Cleaning, transforming, exploration, basic statistical analysis. And when we calculate the average salary, we want to exclude minimum maximum salary, maybe because we, for example, had the we performed the distribution analysis, and we know, okay, so our minimum and maximum salary values are kind of outliers. So we want to exclude them and calculate the average. So this is our method. So this is an important or useful problem to solve today. So I'll give you about 5 minutes to think about solution, idea, anything that you came up, and share your code in the chat. or we can discuss it in 5 minutes. Don't forget to look at the examples to better understand the problem. And you also need to specify Python here instead of other languages. Do you need any help, or do you want to discuss a solution approach?
Let's discuss.
Yeah, so there are many ways maybe we can solve this. Okay, so Abdullah has introduced his attempt. Let's just copy it and also discuss together. Okay, so I want to first discuss and then look at this solution by Abdullah. So how can we calculate the average? We can use just math operators, or we can use some built-in methods. Yeah, and it's the same for minimum and maximum values. There are many ways we can retrieve this. One of the way is just using the for loop, set up the minimum value and then compare if this value that we iterate for is less or more than the minimum value, then it's a minimum or maximum respectively. And we will find the minimum and maximum value this way. But we can also use built-in methods that help to find minimum and maximum value. Instead of iterating over for loop, we can also use some built-in sorting methods to sort the array of numbers. And once we sort it and we know the length of this array, we can then clearly say, okay, the first must be minimum or maximum, and the last must be minimum or maximum, depending on the way we sort it. We can use ascending or descending order. This is the first thing that comes to my mind. So we can use some built-in functions, or we can try to define ourselves, but it's easier when we use built-in functions, right? We can reuse instead of defining them from scratch. Okay, so there are many ways to find minimum, maximum value, average value. Now, what we need to do here is to find average, right? So this is actually what we need to do. Let's see. I want to just show you, for example, if I were you, or when I try to solve it, for example, want to know, okay, Python, and then min, max. Okay, so okay, I here already see there must be some built-in functions, and then I see gigs for gigs, for example. There's examples, explanations how to use these functions, and okay, so we just use max, and that's it, and minimum, that's it. Okay, let's see if we have some Python average of list, for example. Yeah. Again, I'll see here gigs for gigs, for example, and the examples. Okay, so we use some. This is actually what we used for Titanic tutorial. We just use the sum method and len method to find the average. Okay. We can define the average method ourselves and try to use other methods. So basically, we just use sum and length. Okay, while I know this, I then can start to solve this problem. And let's see the Abdullah's solution first. So he defines this average salary. And oh, this is actually what we need to define. And we use this self here. I hope we will start the object-oriented programming soon, and we will understand why we need this. Then we use the remove method, interesting, to remove minimum value of our array, and the same for maximum value. And then, as I already mentioned, we just use sum method and len method to find the average and return average. This is very interesting method. I have not used it before. Let's see. Remove Python array. And we here have W3 school. This is a good, also free resource. Okay. Removing array elements. And interestingly, we don't have, okay, we have here remove method, and we have here first method pop that deletes the elements from the array, and we need to specify the index value. If we specify 1, then the second element will be deleted. We can also use the remove method that Abdullah has introduced. So he used dot notation method and defines the value that we want to remove. Okay, that's nice. let's try to run this. Maybe I'll just copy this to here and delete the rest. Let's just run the code first. Okay, we have here, just a simple mistake. So now we also have a demo how to debug, right? So we have here runtime error, and we don't get frustrated or fear these red lines. We just read it. Okay, global name X is not defined, and we have here a hint where to find our mistake. So here hint is here. Why is that? Because okay, we don't have any definition of X. And why is that? Because we use salary for our input. So just changing this to salary should solve the problem. Let's run code. Okay, it's accepted. So we have passed the test cases that we know. We can actually define here our test cases, visible test cases, and let's submit it just to see how good our algorithm was. Okay, so we have here wrong answer. Why is that? Because we passed some test cases, but hidden test cases are, we failed some hidden test cases. Let's see why. So here we have the input, really long input, and our output is this, but expected is this. Okay. Abdullah or General, when you see this expected output and our output, what do you think is the problem? And I am sure you can answer this question because it is what we already covered.
Like it should be in float. It's written.
Oh, it's written. Okay. Yeah. So when we see here 0, 0, 0, 0, the rounding was done, right? But we shouldn't have any rounding. So let's see. I'll try to sum and length and then convert. Let's try. We should understand where to put the float, right? Maybe just here. Just test it. Okay, success. So why I put float here? Because depending on the divider, the value that we divide on will convert the output of the division. So I put here the float, and we have here some description that we had our code 14%, almost 50% faster than other submissions. And we use 98 or almost 90% less memory than other submissions. I don't think this is a best solution so far, because we can improve it. We can run it a little bit faster, and we can try other methods. For example, we can, for example, let's say I don't know remove method. I can try, say, average is sum of salary, and I'll subtract the minimum value of salary and maximum value of salary, and then divide everything by n minus 2 then, because it's yeah. And maybe I'll do this. I'm not sure if it will increase our speed, but we'll try. Let's just try. Okay, we have some n. Okay, I haven't defined n, so it should be len, right? Len of salary. Okay, remember it was like 36 milliseconds, and here we have 17 milliseconds. So I think this submission should be a little bit faster if it's accepted. Okay, it's accepted, and we increased it to it was like 14, so by 30%. So it's nice improvement. And I think it's already 5 minutes past 6. So I'll just leave you here. And if you're interested, try to optimize this solution. Maybe like for 20 to 30 minutes. And then if you don't came up with other ideas, you can also Google it. You can also look at the discussion board, and you can specify, for example, Python, and see what other solutions people introduced, and try to understand them or try to run them to see what is the rate of their submission. And if you have any question about the solutions that they use, for example, you don't understand why it works, or you want to learn some concepts, let me know. We will cover them in the following sessions. So this is it for today. Bye-bye. Bye-bye.